Welcome back. Tonight's video is going to be over quadratic parent functions and the key attributes. Okay. Now, remember we've been studying quadratics, and this time we're going to be looking at actual graphs. Okay, what the graphs look like and what the functions look like. Now, when we talk about parent functions, we're talking about the simplest possible form of the function. Okay, the simplest possible form. So, what that's going to mean is the function y equals x squared. Okay. Now, if you remember earlier on in Algebra 1, you know that y equals x squared and f of x equals x squared are the same thing. Okay, this is just two different ways of denoting the left-hand side of this equation, this function. Okay, now we want to graph this parent function and see what it looks like, and I've kind of hand-drawn a really rough y and x axis here. And so I'm actually going to graph this f of x equals x squared. Okay, and if we're starting with the x values, you know your ordered pairs, x comma y. Okay, we want to know what is the y value, or output of this function, if we put in an x value of 0. So I want to know what is the output if f of 0 for this function. Okay, which is going to equal, if we look at our function, if x is 0, it's going to be 0 squared, which is the same as saying 0 times 0, and 0 times 0 is just going to be 0. Okay, so if my x value is 0, the y value output is going to be 0, and I get my first point, 0, comma 0. Now let's take a look at an x value of 1. Okay, so we're going to put in input an x value of 1 here. So I want to know, in this function, what if f of 1? What is f of 1? And that's going to be 1 squared, which is the same as saying 1 times 1, or 1. Okay, so if my output is 1, my input is 1, if my x value or input is 1 in this function, then my output is going to be 1. Okay, we get our second point, 1 comma 1. All right, and let's keep going. What if my input is 2? Okay, I want to know what if my input is 2. So f of 2 equals the x value 2 squared, which is the same as saying 2 times 2, or 4. Okay, so if my input is 2, my output is 1, 2, 3, 4. Okay, and that's where I get my second point, 2 comma 4. And last but not least, what if f of 3? That's going to be 3 squared, which is equal to 3 times 3, or 9. So, if my input, my x value is 3, my output is way up here at 9. Okay, 3 comma 9. So there's my next point. Now, let's go on the negative side. What if my input is negative 1? What if my x value is negative 1? Well, that's going to give me negative 1 squared, or negative 1 times negative 1, which is going to be the same as positive 1. Okay, and so we run into this kind of conundrum with squares. Okay, and that is that positive times a positive, as we've seen down this first 3 points here, gives me a positive. But a negative times a negative also yields a positive. So we're going to get this kind of copycat on this left side, the negative values, where we'll run into the same kind of thing. Okay, if my input is negative 2, the output, negative 2 times squared, or negative 2 times negative 2. Once again, we have negative times a negative, so our output is going to be a positive 4. Okay, so there's the point, negative 2 comma 4. Okay, and I'm going to run into the same thing up here with 3. It's going to be 9 again, positive. So negative 3 comma 9. And there are my points for this quadratic curve. Okay, so here's what the parent function looks like when it's graphed. Okay, and we're done. Okay, so that's the graph of the parent function, going through graphing it and everything. And quadratics, if you remember, are always kind of these open curved things that either open upwards or they can open downwards. But since we're looking at the parent function, the positive x squared, then it's going to open upwards. Okay, now I want to talk about a few key attributes here. Attributes or characteristics of this curve that you'll see in every quadratic. And one of them is a minimum slash maximum. Okay, and if we're thinking about minimum slash maximum as an attribute for this curve, what we're looking at is the point where the graph is the lowest or highest. Okay, now here, when we have this opening upwards, okay, when it opens upwards, we're going to get a minimum. But if you look at the graph as it extends on, okay, this arrow means it's going to go to infinity. Okay, it's going to go all the way up to infinity. So we don't really have a maximum in this case. So our minimum for this parent function is going to be the point 0, 0. That's where this curve hits its lowest point, and then it turns back upwards. See? So that's my minimum. Okay. Now, there's also in quadratic curves something called an axis of symmetry. Axis of symmetry. And if we take a look at this curve, and if I graphed it perfectly, okay, you would notice that on this side, it curves up at some rate, right? It keeps curving upwards, reaching to infinity. And on this side, it should curve up in exactly the same way, reaching again to infinity. So if we were to fold this thing right along the axis of symmetry, those two curving lines would match up. Okay, and you'd get the same curve on either side. So here, the axis of symmetry is going to be my x-axis coming down the middle. Okay, if I fold it along the x-axis, technically, both of these curves on either side of my 0 point are going to be the same. Okay, and that's the axis of symmetry. So here my axis of symmetry is the x-axis. I'm sorry, y-axis. Okay, so my axis of symmetry is my y-axis. All right, and there's something else specific with quadratic functions. Okay, you'll always have an axis of symmetry. Now, the last thing I want to talk about in this video is something called a vertex. A vertex. And a vertex is most commonly known as the point at which two rays or two lines or curves meet. Okay, it's a vertex. And this vertex is always, for quadratics, going to be on the axis of symmetry. So here it's on my y-axis. And you'll notice the point at where these two opposite sides of the curve, where it turns back up, is going to be 0, 0. So here, 0, 0 is going to be my vertex. Okay? So things to look at for quadratic functions are going to be minimum or maximum. You will never have both in a quadratic. Okay? You're going to have an axis of symmetry, and you're going to have a vertex. All right? And those are the three kinds of things you'll see in quadratic functions. Now, just for fun, what if we took a look at the function f of x equals negative x squared? Okay? Negative x squared. Well, if we do a quick graph of that function, Okay, what we're going to find is negative x squared does the same thing that x squared does, except on the opposite side of the x-axis. So instead of curving up, negative x squared is going to curve downwards. And so this is where we're going to see a maximum, okay, right there. There's your maximum. And it's going to continue down forever. And please excuse how horribly crooked that x-axis is. But we can see all the same kinds of things there. So this is going to be my maximum, the highest point on that curve. And here, you're going to see, again, the axis of symmetry is still the y-axis, okay? The middle of these two lines, these two curves on either side. So my axis of symmetry is going to be my y-axis, okay? Or the line x equals 0. And the vertex here is still going to be the point 0, comma 0. Okay? And you'll notice also, let's go back to maximum. The maximum occurs at 0, comma 0. Now, for what purpose would a maximum or minimum be relevant? Well, if you're talking about quadratic functions, especially quadratic functions that model a projectile flying through air, perhaps. Okay, so somebody throws, let's say, a football. And we can model this. We can model this throwing of the football as a quadratic curve. Well, the maximum would be the point at which the football reaches the highest. Okay, so I want to know how high is that football going to go. I'm going to look for the maximum in that curve. Okay, and that's pretty much it for parent function of quadratics and some key attributes.